Section 2.1 on quadratic functions. So we're going to start with f of x equals ax squared plus bx plus c, and a cannot equal to 0. If a was equal to 0, the x squared term would cancel out, and we'd just be left with bx plus c, which would be a linear term. So a has to be some number other than 0. So when the equation is in this form, this is called standard form of the parabola. So we can use those a, b's, and c's, the coefficients there, to find different things about the parabola or the quadratic function. So if we look at the graph of a quadratic function, this is just y equals x squared. A quadratic function is always going to have an axis of symmetry, a line that splits it into two equal pieces. And then it's always going to have a vertex somewhere on that axis of symmetry, and that vertex can be a maximum or a minimum depending on which direction the quadratic equation opens. So to get the axis of symmetry, we're going to use x equals negative b over 2a. So you take the b and the a from the formula, plug them in, simplify, and that's always going to give you the axis of symmetry, a vertical line that goes through that number. To get the vertex is on that same line, so they have the same x coordinate. So you're going to use the number that you just got, negative b over 2a, for your x. Then to get the y coordinate, you can just plug that back into the function. So we write f of negative b over 2a. So just plug your x coordinate into the equation, simplify, and that will give you your y. Okay, we also want to know about the x and y intercepts, and we've talked about those before. Remember that the x-intercept is always a number, comma, 0, and the y-intercept is always 0, comma, a number. So you can plug in 0 for that variable and solve for the other variable to find those intercepts. Okay, the next form, f of x equals a parenthesis x minus h all squared plus k, is called the vertex form of a parabola. And when it's in this form, it's a little bit easier to find the axis of symmetry, the vertex, etc. So when the a in front is greater than 0 or it's positive, then your parabola opens up. When a is less than 0 or it's negative, your parabola opens down. X equals h is your axis of symmetry. So that h, when you pull it out of parentheses, is going to change sign. So notice in the parentheses it's a negative h, but when I pull it out to talk about the axis of symmetry, I make it a positive h. The vertex is always h comma k. So again, the same with the h, you change the sign when you pull it out of the parentheses, but the k is going to be the same sign that's in the equation. Okay, so let's look at some examples. So example 1 wants us to graph, identify the vertex, axis of symmetry, and the x and y intercepts. So we're going to find all those things first and then graph it. We're going to start with the axis of symmetry. So for the axis of symmetry, we use x equals negative b over 2a. So the b in my equation is 2. And the a in my equation is negative 1. So it's going to be negative 2 over 2 times negative 1, which is negative 2 over negative 2. And that's going to simplify to just x equals 1. So my axis of symmetry is on the vertical line, x equals 1. So then we're going to find the vertex. For the vertex, we already know the x coordinate. It's x equals 1. Then I'm going to take my 1 and I'm going to plug it into the function and find out what the y is equal to. So negative 1 squared plus 2 times 1 plus 5. And then I'm just going to use order of operations to simplify. So 1 squared is 1, then times the negative 1 out front, then I can do everything else. So it's going to be negative 1 plus 2 plus 5, which simplifies to 6. So our vertex is at 1, 6. Okay, so next we're going to do the x-intercepts. For the x-intercept, we plug in 0 for y, which is the same as f of x. So 0 equals negative x squared plus 2x plus 5. Now to make life easy for us, since that x squared is negative, I'm going to change all the signs by dividing by negative 1. If it's already positive, then don't worry about it. So that just changes all the signs in the equation. X squared minus 2x minus 5. So now we want to solve this trinomial. The only way to solve a trinomial is by factoring. So I'm going to set up my two sets of parentheses, and first I want to see what times what equals x squared. Well, that's going to be x times x. Then I need to know what two things multiply to get 5 and add or subtract to get negative 2. Well, the only thing that multiplies to get 5 is 5 times 1, and there's no way that 5 times 1 or 5 plus 1 is going to get the negative 2 in the middle. So this one does not factor, and if a trinomial doesn't factor, then you have to use the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to go back and we're going to plug in a, b, and c into this formula and simplify. So if I do negative 2 plus or minus the square root of 2 squared minus 4 times negative 1 times 5 divided by 2 times negative 1. Now you can simplify this using order of operations and go step at a time. You can also use your calculator. If you use your calculator, make sure you put lots of parentheses in there and double check to make sure you did it correctly. So when I do it one time with the plus sign, I'm going to get negative 1.45 and then comma 0 because we plugged in 0 for y at the beginning. Then I'm going to do it a second time with the negative sign. So when I type that in, I get positive 3.45 comma 0. So those are my two x-intercepts. So now I need to find the y-intercept. So since I've run out of room, I'm going to go on a new slide. So for the y-intercept, we're going to plug in 0 for y and solve, or 0 for x, and then solve for y. So negative 0 squared plus 2 times 0 plus 5, well, that's just going to simplify to y equals 5. So my y-intercept is 0, 5. So now that we've found all these things, we can use them to graph the parabola. So we're going to start with our vertex, which is at 1, 6. My axis of symmetry is going to go right through that vertex at x equals 1. My x-intercepts were at about negative 1.5 and positive 3.5. And then my y-intercept was at 0, 5. So once you have those points on your graph, then it's easy to see what direction it opens, and you can connect the dots to make your parabola. Okay, example 2, same thing. We're going to graph. We're going to find the vertex, axis of symmetry, and the x and y intercepts. This time our equation is given to us in vertex form, so it makes life a little bit easier in finding those things. So we're going to start with our axis of symmetry. So our axis of symmetry is x equals h. Our h in this equation is going to be negative 5. Remember, when you pull it out of the parentheses, it's going to change sign. Then our vertex is, we already have our x, our h is negative 5, which is the x coordinate, and then your k is the number at the very end, negative 6. So our vertex is negative 5, negative 6. Okay, then for our x-intercept, we're going to plug in 0 for y, and it's a little bit easier to solve on this one. We've got 0 equals x plus 5 all squared minus 6. So we're going to start by adding 6 to both sides. So that's going to give me 6 equals x plus 5 all squared. Well, then I need to take the square root of both sides. And remember, when you take the square root of a number, it's plus or minus the square root of that number. So plus or minus square root of 6 equals x plus 5. Then I need to subtract 5 on both sides. And I would just write it as negative 5 plus or minus the square root of 6. Since I can't take the square root of 6, it's not a whole number, I'll have to type this in the calculator. Once with the plus, once with the minus. So negative 5 plus the square root of 6 is negative 2.55, comma 0. And negative 5 minus the square root of 6 is negative 7.45, comma 0. So those are my x-intercepts. Now for my y-intercept, I'm going to plug in 0 for x. So y equals 0 plus 5 all squared minus 6. So order of operations, I need to add 5 to 0 first. So that's going to be 5. 5 squared is 26. So that's going to be, or 25, which is 25 minus 6, then is 19. So my y-intercept is 0, 19. Okay, so now that I have all of these, I can graph. So we're going to start with our vertex at negative 5, negative 6. Our axis of symmetry should go through that line at negative 5. Our x-intercepts were negative 2.5-ish and negative 7.5-ish. And then our y-intercept was 0, 19, which is off the charts quite a bit, but we can go ahead and make it work on this one. So then I can look at these points and see that this parabola opens up. Okay, now for example 3, we're supposed to write the vertex form of the parabola, and we are given the vertex at 1, 0 and the point 0, 1 that just goes through the parabola. Okay, so your vertex is always HK, and an ordered pair is always an XY. So if I look at the vertex form of the parabola, y equals a times x minus h squared plus k, the only thing I don't have is the a. So to get the a, I'm going to plug into this equation my hk and my xy. So I'm going to skip a step here and just go to the second step. I've plugged in 1 for my y equals a times x was 0 minus 1 for my h, all squared, plus 0 for k. So now I'm just going to simplify to get a by itself. So 1 equals a times 0 minus 1 is going to be negative 1 squared, which will be positive 1. So if 1 equals a times 1, then a has to equal 1. So once I know my a, I'm going to take a and hk and plug them back into vertex form. I don't need my ordered pair anymore. The only purpose of the ordered pair was to find a. So y equals 1 times x minus 1 all squared plus 0. Now, you can do a little bit of simplifying if you need to. The plus 0 isn't doing anything, and the 1 in front of the parenthesis isn't going to change anything. So I would write this as just y equals x minus 1 all squared. Okay, last one, number 4. This one says to write the standard form of the parabola. So we're going to start the same way and do the same steps as number 3, but then we'll have a couple more steps to get it into standard form. Since we can't plug into standard form, we don't have an A, B, and C to plug into. So we're going to start out the same way with our HK and our XY and plug into the vertex form. Okay, so we're going to plug all 4 of these into the equation. Negative 5 equals a times negative 7 minus a negative 3 all squared plus 0. So this is going to be negative 5 equals a times negative 4 squared. Negative 4 squared is 16, so negative 5 equals a times 16. Then I would divide by 16, so a is equal to negative 5 over 16. So we're going to plug a and hk back into our formula. So negative 5 over 16, parenthesis, x minus a negative 3 squared plus 0. So the plus 0 isn't doing anything, and I would change the double negative to a positive. Now, if it asked for vertex form, we would stop right here. But this wants standard form, so we're going to have to simplify this as much as possible. So remember that x plus 3 all squared is the same as x plus 3 times x plus 3. So we actually need to do is multiply x plus 3 times itself before we distribute the negative 5 over 16. So when you do x plus 3 times itself, it turns out to be x squared plus 6x plus 9. Then we'll distribute the negative 5 over 16. And if while you distribute you pay attention to your fractions and simplify as you go, then you should get negative 5 over 16 x squared minus 15 over 8x minus 45 over 16. So this would be standard form of this parabola.